Hey, hello everyone. Thanks for joining us today for today's webinar on using the RespiSim system to manage patient ventilator synchrony in the volume assist control mode. My name is Brian Lin. I am the product manager at Ingmar Medical, and I will be the host for today's webinar. We tried to make today's presentation as concise as possible to be cognizant of your time. So we will try to limit the duration to about 30 total minutes. The first 20 minutes or so will be the presentation, and we will leave at least 10 minutes at the end for questions and answers. We will be muting everyone's audio during the presentation, but feel free to submit questions at any time using the chat panel through Zoom. We will answer as many of your questions as possible after the presentation. And as always, a recording of the webinar will be made available to you via email. You can also access the recordings for any of our previous webinars under the training section of our website. We will be distributing a survey via email as well, so please let us know how we can improve our webinars going forward and provide you with the best webinar experiences. During today's webinar, we will view a pre-recorded simulation featuring a patient who is intubated due to a COPD exacerbation. The scenario will focus specifically on assessing and correcting a trigger synchrony. We will be controlling our patient conditions using the RespiSim software, and we will be showing real ventilator screen captures, as well as assessments that would be viewed by the learner. But one of the main purposes of today's session is to demonstrate the way in which we control these scenarios using the RespiSim software. So for that reason, and I hope this isn't too redundant for those of you who are already familiar with Ingmar, but I'd like to start by providing a quick overview of the approach we take to creating simulations with the RespiSim system. At the heart of the RespiSim system is the ASL 5000 breathing simulator. Within the ASL 5000, there is a piston moving inside of a cylinder. With our software program, we control the movement of the piston to create breathing patterns based on the equation of motion. You can either connect a real ventilator directly to the 22mm port on the front, or we do have multiple options for integrating a mannequin into your simulations as well. We use this technology to simulate lung models that are consistent with a nearly unlimited range of respiratory conditions, such as the ones that you see here. A lung model in the context of our system consists of various resistance, compliance, and spontaneous effort parameters. We do give our users the ability to adjust these parameters interactively during a simulation, and this on-the-fly approach can be effective as a way of demonstrating concepts on the ventilator. But our users can alternatively run and build scenarios that are more structured and comprehensive as well. We call these scenarios curriculum modules. Here you see our instructor dashboard, which is the environment the instructor uses to control our curriculum modules. Within a curriculum module, we have multiple columns which represent the patient's condition at a given point in the scenario. Each of these columns consists of a file containing the breath parameters, the vital signs and blood gases for our patient, and the settings that should be applied to the ventilator at that particular time. By activating one of these columns, the ASL's piston movements adjust according to the new breath parameters, and the patient's vital signs and blood gases are updated for the learner. For each of our curriculum modules, we have built a number of columns which represent our predictions for the decisions our learner will make, both incorrect or correct. When the learner makes a decision to treat the patient, the instructor adjusts the condition of the patient by enabling the appropriate column. Generally, we build scenarios which are designed to address one specific learning objective at a time. So our columns are typically structured to provide you with a range of decisions from least optimal on the far left to most optimal on the far right. In addition to viewing the real ventilator screen, the learner can also be provided with various assessments during the scenario, such as vital signs, blood gases, lab results, X-rays, as well as heart and lung sounds. These assessments can be set to appear on a separate screen that is displayed specifically for the learner during the scenario. Today, we will be demonstrating one of 4 stages within our Trigger to Synchrony curriculum module. Typically, our scenarios take the same initial patient through different stages, each presenting the student with a specific problem to resolve. Our patient today is a 67-year-old, 5'2" female who was admitted to the emergency room and intubated due to impending ventilatory failure. Initially, the patient is sedated but arousable. But for the sake of time, we have skipped ahead to the second stage today. During stage 1 of this scenario, the learner was required to correct for inadequate ventilation by increasing the tidal volume on the ventilator. Now, the simulation has advanced to 4 hours later, at which point our patient has become desynchronous with the ventilator. As the instructor, we can first review all of the information pertinent to the simulation using the instructor guide. The instructor guide provides a case description, learning objectives, an overview of each stage within the scenario, detailed patient information, as well as debriefing questions to review with the learner at the end of the scenario. A similar assessment of the patient's initial condition can be provided directly to the learner by clicking Initial Assessment. Each of the stages in our simulations are referred to as change events, so we will skip to stage number 2 by selecting Change Event 2. By clicking Enable Instructor Setting 1, we have activated our initial patient condition for this stage. In Change Event 1, the patient was sedated but arousable. Now, 4 hours later, the patient has started to wake up from sedation, so they are now breathing spontaneously. As the instructor, we can click Show Lung Model to view the current resistance, compliance, and spontaneous effort parameters for this patient. The instructor will also need to ensure that the correct initial ventilator settings have been applied. The recommended settings are displayed in the Vent Reference Settings section of the current column. We will begin this stage by setting the ventilator to the volume control mode with a tidal volume of 400, an inspiratory time of 0.7, a rate of 16, a PEEP of 5, and a pressure trigger of 3. If we click Show Instructor Actions, you will see a note for the instructor which indicates the patient has become agitated and is showing signs of accessory muscle use. Now that the stage has been set, it is time for our trainee to assess the situation and make a decision on how to treat the patient. The instructor can display the patient's vital signs and blood gas values for the trainee by clicking Display ABG. We can see that this patient is acidotic and tachycardic. Primarily, the trainee will be assessing the information displayed on the ventilator screen. On the ventilator screen, we can see clear signs of a trigger desynchrony issue in both the pressure and flow waveforms. The learning objective of this particular stage is to correct the trigger desynchrony by ensuring the correct trigger parameters are applied. In this case, we will specifically be expecting the learner to change from a pressure trigger to a flow trigger. But let's assume the trainee makes the wrong decision. One potential decision that we have anticipated is that the trainee may decide to increase the rate above 16, but keep the pressure trigger of 3. As the student makes this change, we will enable the column we've prepared for this decision, which includes updated vital signs to reflect the impact of this choice. The instructor actions indicate to the instructor that this will not be effective in correcting the desynchrony, but the trainee should see this evidence on the ventilator screen. By viewing the flow and pressure waveforms, we still see signs of missed triggers. Additionally, we can see on our vital signs monitor that the patient is still tachycardic as well. Now let's assume the trainee makes the correct choice and applies a flow trigger of 2 rather than a pressure trigger of 3. As these settings are applied, the instructor clicks Enable Optimum Setting. Now our learner can again view the ventilator waveforms to see that there is no longer evidence of the trigger desynchrony. Now, if we view our patient's updated vital signs and blood gases, we see indication that the patient's heart rate has dropped and they are less acidotic. This concludes today's scenario, and we would now debrief with the learner. Thanks for watching. So at the conclusion of each stage, the instructor is provided with a note which summarizes the correct decision made by the learner. And this note also provides instructions for proceeding to the next stage of the scenario. So as I mentioned before, we were really focusing today on that one very specific stage, stage number 2 of this particular curriculum module. But we do have over 40 total modules available for our users, covering a range of topics common to mechanical ventilation training. These modules are built by our clinical educators, who are respiratory therapists themselves, and we also work with leading educators in the field of respiratory care to develop scenarios that are aligned with our customers' needs. Though we do use a number of research studies to inform the parameters that are pre-programmed for our scenarios, we do ensure that all aspects of the scenarios, from breath parameters to vital signs and x-rays, are fully editable by our users. This way, you can tailor the scenarios we've created to meet the needs of your curriculum. Okay, so now I would like to open up the floor to the attendees and start fielding some questions. So please feel free to ask us anything you'd like in terms of how we approach simulation using our system or the capabilities of our system, or really anything that you have related to the topics we cover today. Okay, so our first question is, where can I get these scenarios and what is the cost? So I do feel it's important to make it clear that these scenarios that we're talking about today do require the user to own our RespiSim system, which is based on the ASL 5000 breathing simulator. So at the very least, it would be required for you to have those particular tools at your facility. In that case, these scenarios could be purchased to be added and enhancing your current system. And in fact, with initial purchases, we typically do offer a number of modules at no extra cost with the purchase of the system. So another question we have here is related to calibration of the system. So some of you may be wondering what type of preventive maintenance or calibration is required for the system. And Primarily, we are recommending that the ASL 5000 breathing simulator, which is the box which really creates those breathing patterns, we recommend that is calibrated once per year if you're using the system for some sort of research or engineering capacity. But for our educational customers, we recommend calibration to be completed about once every 2 years. The system itself is very well known for being highly accurate and repeatable, and that's actually part of the reason that it's been such a staple of ventilator device development throughout the years of our company. And so that really means that for education, it's in most cases even more accurate than what would be necessary. But it is important to continue to calibrate that on a somewhat regular basis. So for education, as I said, once every 2 years would be the recommendation. So the next question we have here is, for the different disease entities you showed, how many scenarios are there? So I'm assuming that for that question, you were referring to that list of conditions that I had provided earlier in the presentation. And these were really lung models, as I would refer to them, that would again be combinations of resistance, compliance, and effort parameters used to create disease states such as ARDS or COPD or asthma. We have a library of about 36 of those patient conditions created that could be run simply by double-clicking them from our library. And you would be up and running very quickly with that breathing pattern that can be connected to interact with a ventilator. And a lot of our users do use the system that way. I mentioned that interactive approach where you really only need those breath patterns interacting with the ventilator to show some very important concepts. But the scenarios, like we had demonstrated for you today, are much more comprehensive than that in that they include these other assessments, the case description, the recommended ventilator settings, etc. And for that, we have about 45 individual modules that cover some of the topics that I just gave an overview of. I can back up to that slide. So we use those types of respiratory conditions that are breath patterns, essentially, and we use those as a foundation for creating scenarios on the topics that you see here. So our next question here is, are the vital signs displayed on the vent or a computer screen? And if it is a computer screen, can you connect wirelessly? And so to answer the first question, the vital signs are displayed on our simulated vital signs monitor. So that was the screen that you saw a few times during the scenario. I can even back up a little bit here, show you what it looks like. And basically for our pre-created scenarios, we have selected the values that would be displayed there for the student at particular points in the scenario. But you as the user always have the ability to enter your own values or change the ones that we've selected so that the right values appear at the right time on this simulated vital signs monitor. And this is not viewed on the ventilator. The ventilator would be a real ventilator that would display all of the information you would expect to see in a real life situation. It is a window within our software that is typically displayed on a separate screen for the student. So the student would be viewing the screen for information like the vital signs, as well as x-rays, blood gas values, lab results, and things of that nature. Our computers, our computer that's used to control the system can be connected wirelessly. It can also be connected by Ethernet through an ad hoc network that we create using a router. The second screen for displaying the student information is just a simple USB monitor. So it is typically in our primary configuration, that USB monitor is connected using a USB cable to the main computer that's used by the instructor. But that being said, you can really use any sort of external display that you want. And it's basically just an external monitor for dragging over a window and having it appear there. So yeah, so we have another question related to the vital signs, and maybe I clarified that just now, but just to be as clear as possible, this separate monitor for the student is just a small USB monitor. So it is connected by USB to the main computer that's used by the instructor. And that computer used by the instructor can be connected wirelessly. And that can certainly be contained in a sort of a simulation environment where you might have a control room. So we can certainly accommodate that type of configuration where you would be controlling the simulation from a separate room because that instructor computer can be connected wirelessly. So we do have another question. So still related to the vital signs monitor. The vital signs monitor is normally an extended screen, but can it be projected over Wi-Fi? We have just now started using them. I really like your product. Thanks, Tim. I really appreciate that feedback as well. And so in the configuration that I believe you have, that USB monitor cannot be connected wirelessly. We don't have a way of doing that. So that monitor that we included with your system would need to be connected by USB. Of course, if you want it to be, considerably far away from your instructor computer, you could use a long USB cable. Alternatively, you could really use any extended display that you have available to you. So if your center has, monitors or audiovisual equipment that you want to incorporate, that can certainly be accommodated. In fact, we have a technical support team here that really deals with a lot of those connectivity and setup challenges that customers may have. So please feel free to reach out to us directly if you have further questions and would require further assistance getting the specific setup that you need. Okay, it looks like I answered your question there. Again, thanks, Tim. Thanks, Dana. Thanks, Jackie. Thanks, everyone, for joining us here today. We do understand that there is a bit of a learning curve with the system. Unfortunately, that is part of the nature of simulating some of these very complex and sophisticated scenarios. So we are certainly working hard to understand, what our customers need and how they can make the best use of our system. And we definitely plan to continue having events like this where we are providing some information to help you get more out of your system. So again, thank you very much. And unless you have any further questions, I think we'll leave it there for today. But as I mentioned before, feel free to reach out to us directly with any more specific questions. We're always happy to help. And please, if you don't mind, fill out the survey that you'll receive via email so that we can get some additional feedback. And we look forward to presenting for you the next time around.